Hey everyone, welcome back to the channel Devotion of Knowledge. Today we are back again with another YouTube video, and in this video we are going to discuss a lead code daily problem which is named Domino, a number of equivalent domino pairs, and it is an easy tagged problem. And basically, this problem is easy also, but there is only one catch that many people are not able to find, even though it took me some time as well to optimize the logic from n log n to amortized of n. We will be understanding how I did it and what's the main logic. So, mainly the question states that we are given dominoes A and B and dominoes C and D. Now, both the pairs a and B, C and D, this is the pair of domino. Now these two are considered as equal if and only if A is equal to C, or A is equal to D, B is equal to C, or B is equal to D. Means it is trying to say that make it sorted and it is equal to each other. So yeah, that's the main thing the question is trying to say. So yeah, let us understand it using an example. First case is 1 2 2 1 3 4 5 6. Yes. Now as condition is A is equal to C, B equal to D, A equal to, or B equal to C. So here as you can see, A is equal to D and 2 is equal to 2 here. So there is one pair which is equal to each other. So answer is 1. Similarly, this is another case 1 2 1 2 1 1 1 2 2 and 2. So if you can notice or observe, 1 2 and 3 are equal pairs. So how they are equal? This can make pair with this one this, and this with this. So basically the answer will be n to n minus 1 by 2, where n equal to equal pairs. Yeah, so I hope this much logic is clear. So first approach that would come into mind is obviously brute force. Whatever the domino values we are given, just check it with all the rest of the elements, find the corresponding answer. Now here this update the answer. So basically you do nothing, just compare it with rest of compare this with the rest of the array, this with the rest of the array. So it will be O of n square approach, and space complexity will be constant. Now, can we somewhat optimize this problem? Yes, definitely. How? Let us see. Optimized approach. For example, here we are given some of the values. Let us say AB is given here, CD, AB, BA, DE, FG, whatever dummy values I have taken here. So here AB is given. All these are equal pairs. So can I design some data structure in which I can store these pairs so that I don't have to compare each and every value for brute force approach, obviously. So is there any data structure which can store something like frequency and all that? Yes, you heard it right. Hash map is the data structure which can store the frequencies and all that. So we will be storing these values into data structure, and as it you can see, AB is equal to BA, but the values are swapped. So here we will be making sure that we store data in hash map in sorted form, sorted, or I would say A greater than B form. And once we have got all the values, for example, A comma B's frequency is 3 here, C comma D is 1, D comma E is also 1, F comma G is also 1. So this is the hash map that we have obtained, and what will be the answer, as it is equal to 3. So number of pairs it can be forming across themselves is equal to 3 into 2 by 2 equal to 3. All of this will be giving us answer 0. So this is the simple approach using hash map. Let us see the code as well using hash map. Okay, this is the code. Just a second. Okay. So initializing map, dominoes.size, and taking the instance of the vector. If it greater than 0, then we will be storing in smaller value first, else obviously smaller value. So we will be storing in format a greater than b. After that, we will be iterating into the map. id.second denotes frequency. So x into x minus 1 by 2 is the answer, and we'll be just incrementing the answer value by this x into x minus 1 by 2 and returning final answer. Okay, so this is the main logic. Now the complexity is n log n, I would say, because yeah, frequency will be n log n because initially we are iterating through 0 to n, and here we are inserting values into map. Now this takes O of log n, so combinedly it will be O of n log n. Can this be optimized further? This is my question. This is the main catch. This is the main catch. Okay, sorry. This is the main. Yes, this is the main catch. Can we optimize it further? More optimization. Okay, the hash map is the most, obvious data structure that we can use. But is there any further data structure as well which can support this operations into more better time complexity? Yes or no? Is there any data structure? Yes. Answer would be yes, because unordered map is the main data structure that can support these operations into amortized O of n. Okay, sorry. Amortized O of 1. Now, those who are not aware about amortized O of 1, it is mainly meaning average. We will be taking time complexity of n operations, and when we carry out average, it will be O of 1, because some operations might be O of n, some operations might be taking less than O of 1. So at the end, it will be O of 1 for each operation. So yes, unordered map is the solution that we can use. But the only problem is, here we are in map, as you can see, here we are storing pair of integer comma integer as a key and integer as a value. Now, unordered map is something which is not a tree based data structure. It is not tree based, because in map and set we use red black trees, but unordered map is not something which is tree based. It is based on hash values. So in C++, nesting of pair or pair of integer as key and integer as value, this format has some corresponding hash value, and this is not defined for unordered map. So we have to do some jugaad here. What we will be doing? We are given A and B. Can we represent this A and B into something which is unique every time? Because key should be unique every time, to make sure that corresponding data stored with the corresponding key is always unique or stored in respect of value with the unique key only. Is there any catch, or is there any concept using which we can formulate any automata or something like that which can be unique for A and B? I would say yes. We can represent A comma B as 10 star A plus B. It is nothing. If A and B are 1 and 2, then this will give us 12, which it is nothing but just a numeric representation of A and B. If A and B is 3 comma 4, 3 into 10 plus 4 equal to 30 plus 4, which will be giving us nothing but just 34. So this is basically an integer, and frequency is also integer. So we can change this pair of integer comma integer to just integer and integer, which is defined for an ordered map. So we'll be doing this thing, and that is my code. Yes, here it is. Here is the simple code. Unordered map, integer comma integer. We took A and B because minimum, I would say, and just formulating A star 10 plus B and increasing the frequency, and finally x into x minus 1 by 2 was our answer. And let me show you my submissions. This beats almost 100%. So this is the most optimized approach that one can learn for this problem, which is optimizing from pair of integer comma integer to integer, and this complexity is O of n, while in hash map it was O of n log n. So I hope the concept is clear to you people. I hope you will also attempt this problem. If you have enjoyed the explanation and approach towards the question, please make sure you follow the channel for more such similar content on regular basis. We will be meeting in the next video very soon. Till then, keep learning, keep hard working. Thank you very much.